This is Cosmographia, the Randall Carlson podcast. Welcome back, ladies and gentlemen, to Cosmographia, the Randall Carlson podcast. We are joined today by all the usual people. We got Bradley. How you doing, sir?
I'm good, man. Good to see you guys. We're back.
Yeah, good to see you too. Yes, we are back. Mike, how about you? Normal guy land. Silent Mike. Randall.
Sir.
How are you doing today? Yeah. How's it going?
Going pretty good, man. Yeah, what Excellent. Can I say?
Yeah, life is good.
Well, yeah, I mean, the new website's up. The restaurant's all legal and approved, so it's opening a week from tonight. And by the time this is posted, the Wheelhouse Craft Pub and Kitchen will be open for business.
All right.
Great news.
Get down there and get me a sandwich.
Better. You guys better show up, come on up, and try out the menu.
Yeah, I'd love to.
The black and tan.
The black and tans. I can't wait to do that.
To have a secret passcode for Cosmographia listeners that show up at the Wheelhouse.
Oh, there we go. Yeah,
Scott Boulevard. Hey,
I think you need to.
What's your deal, man? Yeah,
I think you need to do a remote from one of the booths there.
There we go.
Yeah,
we can do that.
You know what? It would be fun to do a podcast from there.
Yeah,
we talked about having Ian on, so that's the way to have Ian on. Let him show us around the pub.
Yeah. If people go to the new website and they see the how tube that we're partnering with, and I've got the 5 regular polyhedra, they're arrayed. That's on the bar that we built.
Yeah,
the Brazilian tigerwood bar. And at some point we should show some pictures of that place. It's quite a little masterpiece.
Yeah, who was the model that you got to hold the pyramid?
I don't know, one of these pretentious, pretty boys that we had to pay a lot of money to,
That's what I thought. I was like, where did they get this guy?
Yeah.
So the top of the website homepage has got sliders that you can move right and left and see the graphics from the latest podcast. But if you scroll down, I think that's like the next thing below. So
that's right. The store is great. I love the first 3 blog posts. So definitely. It's looking good. Yeah.
Yeah, I'm excited about it.
Congratulations.
Yeah. That's right. Congratulations.
All right. So, let's have a little recap of our last episode. Brad, you want to take us?
Brad? Kyle's got some notes.
I know. Kyle, you got the notes.
Well, we talked about Lake Hind.
Yeah, Lake Hind. We are going to continue with Lake Hind, by the way.
Yeah, the 1995 Teller paper. Multi-proxy study in Manitoba, Canada.
Mm-hmm.
I took some different notes. One thing I thought was interesting is that the uplifts are not uniform. That's really key to me.
The uplifts.
The uplifts are not uniform necessarily. You went over the ice dams. We talked about,
I did that.
The ice dam is less dense than the water. Great point.
Important point. A point that seems to be overlooked.
Ignored. Yeah.
Yes. We talked about high energy seismic pulse.
All right.
The meridional overturning circulation in the Atlantic. Then we talked about Oak Lake and the arcuate feature there. I think that was one of the last slides.
That's right.
Yeah.
You started talking about Oak Lake and seeing the draining of Oak Lake to one side, and then on the other side there's this nice arcuate. Arcuate.
There's a good word for you there, Kyle. Arcuate.
Mm-hmm. Still remember it from episode 21.
Feature.
Yeah, 120, 150 degrees. It's a good ways around a circle.
Mm-hmm.
Yeah.
Curious.
So what I was emphasizing that I thought was particularly interesting about Lake Hind was you have the comet researchers and the glaciofluvial flood researchers coming together there, which is something that I've been trying to think needed to happen for several decades at least. That, we should seriously consider that, a cosmic impact might be involved in some of the melting that occurred. But nobody seemed too interested in it. I was always surprised that nobody was looking at that, even back, in the early 90s. When I was taking geology courses, one of the papers I wrote was dealing directly with that idea. But I was always surprised that no one seemed to be going there. But it seemed that the idea of the ice dam was just so entrenched and so accepted that nobody was questioning that. It was a question of, peak discharges and the number of floods, that sort of thing, rather than the actual efficacy of glacial ice to form any kind of a viable ice dam that could retain water under any substantial pressure. So, and really the ice dam idea goes back to, I believe it was T.C. Chamberlain in the 1890s who first proposed the idea of an ice dam in the Idaho Panhandle, because there was already some of the early observers in there begin to see the evidence of a vast body of water contained within the western mountain valley, the mountain valleys of western Montana. So the idea of a large proglacial lake was already there on the intellectual horizon by the 1890s, and it was, like I said, I think it was T.C. Chamberlain that distinguished, one of the godfathers of modern geological science, speculated that it may have been an ice dam, and that idea has kind of persisted ever since then. I look at it as being kind of actually, I think I misspoke, to the 1890s. So it's a 19th century idea. So I'm arguing that it's time to kind of take a relook at that idea rather than trying to fit all the models around the idea of a glacially impounded lake. Because you see, we'll of course be coming back to this now that we're getting into the idea of glacial megafloods. But the thing is that glacial Lake Missoula is a really big mass of water. And I'm going to do a graphic, probably I'll hope to have it ready for the next podcast, where to try to convey some sense of just how much water we're talking about when we're talking about in excess of 600 cubic miles of water. It seems like, as far as the origins of the flood, it's like they're kicking it up, one step up the hierarchy, but they're stopping there and just saying, oh, well, the flood came from glacial Lake Missoula. Well, there was 45 floods or 40 floods, 40 drainings of Lake Missoula. And then the number kept increasing until it was up now over 90 separate floods, right? Now, first of all, we have to define what we mean by a megaflood, right? Was there 90 separate fluvial events that left traces throughout the Channeled Scabland landscape? Yes, I think there was. But how many actual megafloods that could be then blamed upon the draining of the 600 cubic miles of water from the basin of Lake Missoula that was in turn impounded by an ice dam? I think that's a relatively shaky idea. And the question I would repeatedly ask is, okay, you're saying that the flood that created Grand Coulee or even Moses Coulee came out of western Montana as part of Lake Missoula that was held in by an ice dam? Well, where did Lake Missoula come from? Where did 600 cubic miles of water in the western mountain valleys of Montana come from? How do you accumulate that much water? See, that's my issue, and that's what we're going to explore. We're going to explore that idea really in depth as we go here.
Did you say that you think there were many, many floods, but you're just questioning?
What I'm saying is that, yes, there were many flood events through that landscape, But what I would also say is that I think we're looking at floods of several that vary by as much as an order or two of magnitude, right? Because to my way of thinking, what we have to do is we have to look at the floods there in the context of the melting away of the entire southern Cordilleran ice complex, which covered the region from northern Washington all the way up to central British Columbia. So you had this huge ice sheet covering most of British Columbia up into the Yukon and into part of Alaska, and it reached down into Washington, right? Well, when you go up to roughly Prince George is where you have a major watershed divide, and everything south of there is basically draining south, ultimately into the Columbia watershed or into the Fraser River watershed. Now, the Columbia watershed is going to take that water down and spill it out across the Columbia Basalt Plateau. The Fraser watershed is going to dump it out right there at Juan de Fuca, right there near where Vancouver is now. Dump it right into the Pacific Ocean at Vancouver, bypassing the Scablands. But ultimately, it's all coming from this vast ice complex that's over the Canadian Rockies and over the plateau country. So we're going to look at all that. I mean, you know, we've got the maps, the topo maps, the aerial footage, the Google Earth. We've got drone footage. We've got a lot of video and photos from the ground level. So we're going to be correlating all that to try to get a really comprehensive picture of what actually happened and where the water for these floods that created the Channeled Scablands ultimately came from. Now, tomorrow, Brad and I are going to have a preliminary Zoom test meeting with Dr. Jerome Lessman. He's a professor of geology at Vancouver Island University. He's the one we spent 4 days out in the field with, looking at megaflood features up in plateau country of BC, British Columbia, and went up to the drumlin fields with him. And so we're going to be talking drumlins and other things. We may even get him on here for a couple of episodes, because Jerome Lessman co-authored a critical paper in 1999 that synchronously came out. See, Brad and I made our first recon trip over the Scablands in 98 with the idea in mind that we were looking if we could see evidence that there was other sources of water contributing to the floods other than glacial Lake Missoula, right? So in our second excursion out, which was the next summer in August, we went to BC because to look for geomorphic evidence in the field that here was where some of the sources of meltwater were. So we had probably gotten our plane tickets 6 weeks in advance. We were ready to go. And then Geology, the journal Geology, comes out with a feature article written by lead author John Shaw, who, of course, was in the forefront of this reinterpretation of the origin of drumlins. Came up with a radical theory that they were actually produced by gigantic high-pressure subglacial floods that we've talked about, right? And we're going to come back to that because drumlins are key to understanding a lot of this. So anyways,
that was the paper too, right? Back to Bretz.
Back to Bretz. What did he mean by back to Bretz? Now, who's Bretz, Kyle?
Bretz is a geologist who first theorized that the Missoula, that the flood from Missoula was caused by catastrophic. Basically, the early catastrophist, I should just say.
Okay, well, yeah, that was
a drumlin guy.
I guess that was your best effort.
It was pretty weak.
It was weak, Kyle.
Well, he theorized that there was one massive flood in Lake Missoula.
No.
And No?
No.
Okay. Yeah. What did I do wrong here?
And see, this is the key why the paper is called Back to Bretz. Because when he first proposed, what he was doing, he was looking at the Channeled Scablands, this erosional complex of southeastern Washington, right? He was not looking in Montana.
Oh, okay.
Because what he was doing was he was looking at the Channeled Scabland complex, and his conclusion was that it was caused by an accelerated melting of the southern portion of the Cordilleran Ice Sheet.
Okay, yeah.
That was his original concept. Well, all of his critics attacked him and said, well, where did the water come from? Okay, accelerated melting. Well, what would cause this accelerated melting where you would have these giant floods? Because that's a lot of accelerated melting.
Yeah.
So, volcanism, then they looked around. There was not enough volcanoes up there to melt the volume of water that he was invoking to explain the formation of the Channeled Scablands. Well, some kind of, he tried to come up with something that could cause an accelerated melting. He didn't really come up with anything. He came up with was tentative and immediately got shot down by his critics. Yeah. So the critics said, well, you cannot supply a source for the giant flood that you said create the Channeled Scabland. Therefore, no giant flood happened.
Right.
That was essentially the argument for decades. And then parallel to that, unbeknownst, interesting year, go back to the year 1910. J. Harlen Bretz is a young high school science teacher, and he loved to study a lot of the newly released U.S. Geological Survey topo maps. He had just received a 1 to 24,000 scale topo map that showed Potholes Cataract. And he was looking, this is 1910, he's looking at that and going, what is this? What is this feature? He was trying to explain it in his mind. He couldn't get that idea out of his mind for like 7 or 8 years, and then finally he was led to go and start looking at the Scablands firsthand, and he did several field years out there looking at stuff. I think the first paper was published in 1923. He actually published some papers before that were documenting evidence for huge occurrences of huge volumes of water throughout the Columbia River area, the lower Columbia and the Columbia Gorge and stuff. But at that point, he hadn't gotten far enough east to really begin to study the Scablands. So when he got to the Scablands, he began, multiple year-long, seasonal excursions out. And he always took students with him because now by this time, he's gone from being a high school teacher to I think he's now teaching college. So, and I think he was at the University of Chicago. So he's taking these students out in the field, and they're spending the summer mapping the Channeled Scablands. So I think about 1927 is when he produced his first paper that had an actual map of the Channeled Scablands that he and his students came up with by arduously and laboriously crisscrossing back and forth southeastern Washington, measuring and taking elevations and stuff. Remarkably, when you look at that map that they came up with, it's very close. So, you can look at it next to Google Earth and you'll see how remarkably close they actually came. But all of this time, he's thinking the water came from the north. He's thinking that the water came from this sudden melting of the southern portion of the Cordilleran Ice Sheet. He's not even thinking about a lake over in western Montana, 200, 300 miles to the east. Well, also in 1910, there was a young geologist by the name of J.T. Pardee, who went to the work for the U.S. Geological Survey, and he published his first paper in 1910, which was entitled Glacial Lake Missoula. So he had spent several seasons studying the deposits in the valley bottom and noting that there were shorelines up on the mountainsides, correlating all of this. And of course, he was inspired by the original that I mentioned earlier, T.C. Chamberlain's comment that there might have been an ice dam in some western reach of this, at that point, unnamed lake, but that this ice dam had created the lake. So Pardee was in these mountain valleys, and he was looking at the sediments on the valley floor and going, these are lake sediments. These are typical lake sediments. And he finds these sediments extensively distributed, throughout these mountain valleys. Then he takes note of the shoreline. So between those two things, he theorizes that there had been a vast lake there, and he publishes this paper in 1910. First paper, right? Okay, so that was the first paper of his career. Interestingly, 1944, I believe it was, 42, 44, the last paper of his career So he did all kinds of stuff between 1910 and his retirement in early 1940s. His first paper, Lake Missoula. His last paper was about Lake Missoula, like bookends to his career. The last paper that he wrote in the 40s was entitled Unusual Currents in Glacial Lake Missoula. Unusual. That was his way, his non-emotive way of describing what he'd discovered, which was gigantic current ripples. Well, what that led him to believe is that, wow, he'd already concluded there was this big volume, big body of water there. Now when he sees these current ripples, then he also notices that there's, along the hillsides, many of the hillsides, there's scoured rock up. And by measuring, taking repeated elevations of the top of the scouring, he was able to conclude that the high water level rose to 4,200 feet above sea level. Okay, so now when you go into the basin of the Missoula Basin, where the town of Missoula is, you go to the campus at the University of Montana there, and there's two mountains, Mount Sentinel and Mount Jumbo. Very conspicuous shorelines on those mountains, right? 4,200 feet above sea level. Now, the valley floor is about 3,000 feet above sea level. So that means that in that basin right there, you can easily figure out that the water was up, maybe it was 3,200, because the water there was about 1,000 feet deep. But now as you go to the west, and as you're going, now all of this is part of the Clark Fork River watershed that ultimately is now drains into Lake Pend Oreille, northern Idaho Panhandle. As you go west, the gradient is dropping. So by the time you get to Lake Pend Oreille, right where you get to roughly, you're in the Clark Fork Valley, you're at the border between Montana and Idaho, you're now at about 2,100 feet above sea level. The scouring on the mountainsides is 4,200 feet above sea level. So he was able to go, wait, gosh, here's the scouring on the mountainsides in the Clark Fork River Valley, and 150 miles away or so, or 100 miles away, he had found shorelines that were also 4,200 feet above sea level. Okay, so from all this, he'd been mapping this vast region where this huge body of water had accumulated and called it Lake Missoula, right? Well, in his early 40s paper, he had discovered the giant current ripples. And one of these current ripple fields was in a place called Camas Prairie. And Camas Prairie is near Flathead Lake. It's right to the west of Flathead Lake. And in Camas Prairie, there's this massive ripple train. We're going to be looking at pictures, video. Brad's got drone footage. We've been there many times. And when you look at the anatomy of these ripples, what you see is that they're composed of really coarse gravel and boulders and everything like this. It's a huge mass of material. The total ripple train itself is almost 5 miles long. And it diminishes from maximum size at the north end to where it sort of disappears at the south end, about 5 miles away. And where the current ripples are the biggest at the north end, the amplitude ranges between about 30 and 50 feet. The wavelength varies anywhere between 200 up to a maximum, I'm thinking, of about 500 feet. So when you're in one of the troughs, you don't even really see, you can't see over. It's like, you'd be standing there and these hills are like a 5-story building on each side of you. So, okay, to make a long story short, if that's even possible, J.T. Pardee discovered, he didn't discover, but he certainly elaborated on the idea and made it a scientifically accepted model, Glacial Lake Missoula. So, in the I believe it was 1940. I don't remember the exact date, but James Galooly, who was one of the leading critics, organized this conference in Washington, D.C. We've talked about that, where he invited Bretz to supposedly get a fair hearing for his, outrageous catastrophic flood hypothesis. But what it really was an ambush where he got a lot of people sympathetic to his side, and their goal was to essentially put an end to this giant flood heresy before people took it and said, oh, this was Noah's flood, and oh, here we are right back to biblical diluvialism again and all of that. Well, JT Pardee ended up at that conference, at that meeting, in that meeting room. And he was listening to the whole thing as Bretz is laying out his case, making his case that the Channeled Scablands of eastern Washington had been created by this really huge catastrophic flood. Although I think by this time, I believe Bretz was already thinking there might have been 2 floods or even 3 floods, right? In any case, Pardee didn't say much. In fact, didn't say anything apparently until the end of the conference, when he leaned over to one of his colleagues and whispered to him and said, I know where Bretz's flood came from. And this was where Lake Missoula, Channeled Scablands come together right there. Now, geological mainstream community, which is heavily invested in the idea of uniformitarianism, the idea that whatever happened in the past, we have to explain it by reference to a modern process. Well, see, this provided the uniformitarian way out for the critics, because now what they would do is go, oh, there we go. It was a glacial ice dam. It was an outburst flood. We've seen those in Iceland. We've seen those in Alaska. We've seen them in British Columbia, where an ice dam, particularly because, by the 1940s now, the Little Ice Age has been going away for 100 years, right? Well, remember, the Little Ice Age, the planet's glaciers grew bigger, or as big or bigger than they had been in 11 or 12,000 years, right? They weren't that big, but it was the biggest the glaciers had grown throughout the entire Holocene. So that's a point to keep in mind. Mm-hmm. Little Ice Age. Yeah, these glaciers were big. So they started receding in the early to mid 19th century. As they receded, they created proglacial lakes. So the northern climates that were glaciated during the Little Ice Age underwent a century to 2 centuries of Jökulhlaups, which is the Icelandic term for these glacial outburst floods. Now, what seems to be happening is, because the glaciers have receded to the extent that they have, is that this episode of these semi-catastrophic floods seems to be waning, right? Because you picture 150 years ago, many of these glaciers were 3 times the size they are now, 4 times the size. So obviously, when they're melting back, they're producing copious amounts of meltwater. In some cases, like, for example, if you have a trunk glacier that's melting back, and you've got a tributary glacier that's melting back, and you've got a main trunk glacier that's going to be much more massive. It's going to take longer to melt, right? Well, what'll happen? The tributary valleys melt, and they pond against the main valley trunk glacier.
That's understandable.
Yes. Now, when that main trunk valley glacier melts to a certain extent, at some point, the water kind of overcomes the glacier and it can't retain it anymore. Typically, the water sometimes will overtop, but usually it forces its way under. And once it gets under and starts piping, that erosional process proceeds exponentially. And boom, you have an outburst flood. The lake drains, the tunnel, the outlet will seal, right? And the water will begin accumulating again. And then maybe the next year, several years later, the process will repeat. And these are referred to as self-dumping ice-dammed lakes. And they'll go through this process until the glaciers are basically gone, right? Now, here's the thing. Coming back to the Bretz, because of the fact that geologists have been seeing this going on, they said, well, there's our explanation. You had glacial Lake Missoula held in by a glacial dam. The glacial dam gave way in the same fashion that we witnessed, in the last 50 years, say, of ice-dammed lakes breaking out in Alaska or, Canada, British Columbia, wherever they might have been, right? One problem, though, that seemed to have been sort of, in my mind, kind of neglected and overlooked.
you needed 600 cubic miles of water to refill the lake.
Yes, and the problem is, and we're going to show this because I've got a massive amount of really interesting information about processes and effects of modern outburst floods. Because remember the scale and variance phenomenon, we can look at smaller stuff to get the bigger picture. But when we look at the modern outburst floods, what we're going to be confronted with when we start looking at peak discharges and maximum volumes is that the amount of water for the Missoula floods is typically more than 1,000 times greater than the modern scale of outburst floods. That to me is a proportional situation. It can't just be overlooked. And it's been referenced. I'll show you some of the references I've got. We're saying, well, yeah, it's three orders of magnitude larger than any known outburst flood, but then they go right on. And then I recall I got one paper here which says, well, it is a major extrapolation of the data. Yes, it's a very major extrapolation. Can we just go, okay, we're going to take a modern glacially dammed lake and an consequent outburst flood, scale it up by 3 orders of magnitude and say, no problem. See, that's where I start having a problem with it.
Yeah, why are they okay with doing that, with that process, but not with just a flood that has no dam involved? No ice dam. Why can't we just scale that up until it's big enough to cause the whole thing?
Well, because you have no way. And see, this is when we get back into the energy paradox we've referred to. Where's the energy come to melt that much? You got to have energy. You got to have heat to melt that much water that fast.
Right.
That's the problem.
SUVs, man.
What's that, Kyle?
No, there was a bad throwaway comment. SUVs. SUVs will do it.
Well, okay.
Cut that part out, Brad.
My theory was that, it was, all the woolly mammoths, 10 million woolly mammoths.
Oh, yeah.
Clearly.
Flatulating.
It was, there was a sudden simultaneous increase in methane expulsions.
That's right.
Which caused a rapid catastrophic global warming. So
I just want you to know that all that stuff that you just said is what I meant to say about Bretz.
Right. I knew that. That's why I was trying to help you out a little bit there.
I got nervous. I got nervous.
Well, don't worry, because we're going to recap this next week, and then you'll get to basically re-expound the entire thing that I just laid out.
All right.
In detail.
Yep. So
let's go back to Lake.
I did want to slightly, take a moment though to address Russ's question about the multiple floods.
Yeah.
Just to say that it's extremely complex. You can go to some places and there's evidence for what looks like 40 floods. You can go to other places and it looks like, well, they've had 90 floods. Some places it looks like 2 huge floods. So there's many different reasons for some places getting washed away and recreating the landscape. So there's not evidence of the previous floods. So, I mean, it's very complex. There's different reasons for there being different quantities of floods that have been hypothesized.
And we will explore all those reasons for the most part.
All right.
And I the number of comments over the years, not a whole bunch, but probably half a dozen comments where I think there was a recent one, and I think one of you guys forwarded to me. Somebody was saying, well, they watched one of Nick Zentner's videos, and what did he say? That blew my single flood hypothesis
out of the water. Yeah.
Yeah. Something like that. It blows holes in my single flood hypothesis. I've been thinking, now, wait a minute. What single flood hypothesis would that be?
Yeah.
I mean,
and he should have said blown it out of the water because,
Yeah, right. I mean, it should have. Yeah. No. Clearly, it's like Brad said, it's much more complex than that. Bretz was certainly at that point. But see, what then happened was that with the acceptance of the gigantic flood as a possibility, with the adaptation or the adoption of the glacial outburst flood model, it now became academically acceptable. to talk about this flood, see, and
huge
accept
flood,
the flood.
yeah.
And Bretz's original idea of accelerated melting of the Cordilleran Ice Sheet basically got abandoned, even by Bretz. Although I have a suspicion that even for the rest of his life, which went on for quite a few more years, like another 30 years. I mean, he was 96 when he passed away. That he might have not been fully 100% comfortable with the whole ice dam model. And maybe somewhere in the back of his mind was still trying to come up with some way to explain an accelerated melting. Okay, well, now to get it back to what we started with was this paper that came out in 1999, right? Which was entitled Back to Bretz. Now, do you see the significance of the title, Back to Bretz? Yeah. Going back to the idea that maybe that there was at least part of this flood phenomena that came from Canada, that came from British Columbia. That was the significance of that. So for me, what was so exciting was that Brad and I had this idea. We're going to go back. We've got our tickets next month. A few weeks in the future, we're going to go to British Columbia and explore these places. We're going to go up the Rocky Mountain Trench. We're going to look at the Fraser River Valley. We're going to go up into the Okanagan Valley, right? July, this paper comes out. Lead author, John Shaw. Jerome Lessman, I think at that point, we can ask him, but I think at that point he was a graduate student. He was one of the co-authors of this paper, Back to Bretz. Mm-hmm. So here, this was like confirmation that we were on to something. Because here they are saying, well, we need to look up in British Columbia that there may have been at least some of the water contributing to the formation of the Channeled Scablands may have come from elsewhere than Lake Missoula. But see, to me, that was like the little Dutch boy, he's holding his finger in the ice dam, and you've got 960 PSI behind that ice dam, 2,100 feet deep, and he's got his finger on that ice dam. And that paper to me was, that water starts trickling through. And first it comes through slow, and then it gets, as the conduit enlarges, so does the erosion increases exponentially. Everything I've learned since then, with repeated trips back to British Columbia, a lot of new papers that have come out, and so on, absolutely, I would say that the water that created the Channeled Scablands ultimately came from southern Canada, came from southern British Columbia, and I'll even go further than that, and I will say that the water that's made up Glacial Lake Missoula came from the same source. And when we look at the topography, you'll begin to understand, I think, what we're seeing is massive multiple rushes of meltwater south. When it hits the basalt plateau, that basalt plateau is all tilted down to the southeast. So any water coming off the glaciers that have just encroached upon the northern rim of the basalt plateau, that water is going to rush at a high velocity over the plateau, right? And then it's going to make its way, it's going to come to that focal point at Wallula Gap, which we will be looking at, and which, by the way, we have a video of Brad and I and Graham Hancock at Wallula Gap, which people can watch because it's on the new website. All that water is coming down, and it's highly erosive. It creates the Channeled Scablands, right? Go a little further east, and that meltwater that's coming down over Canada is rushing into a series of mountain valleys that have no outlet except the Clark Fork River Valley to the east. So essentially, I would interpret Lake Missoula, is a very large backflood, temporary impoundment of water held temporarily against the ice lobe, which was the Pend d'Oreille ice lobe.
By the water itself.
Yes. Yeah. But that ice lobe did not sit there in a static position for 50 or 100 years while the water slowly rose behind it. The water very fast rose behind it and quickly discharged through and washed the whole ice lobe away, which it would have had to have done in order to reach peak discharges of 700 to 800 million cubic feet per second. The entire ice lobe is gone. And of course, all of this is going to become apparent to people once we start pulling out the maps and the graphics and stuff, and you can begin to see for yourself. We'll be looking at the video clips and all of that. Okay, and so Jerome Lessman has been studying the drumlins because that's what John Shaw did. And there's some parallels here because John Shaw, if you start looking at the literature on drumlins, what you're going to find out is that there's hundreds of articles written and probably 100 different ideas about the origin of drumlins. And the origin of drumlins has always eluded the geologists. One of the things to know is that the drumlins are always found in areas that would have been under the ice sheet. They're not really found outside the ice sheet. They're under the ice sheet, right? And we know where the ice sheet's terminated because there's terminal moraines there, right? So, for example, in western New York, there's terminal moraines at the south end in the area of the Finger Lakes, right? North of there's where we find the drumlin fields. Same thing, we can go to Wisconsin, same thing. Go to Ireland, same thing. You find the terminal moraines, the drumlin fields are behind the terminal moraines, right? So the drumlins formed under the glaciers. The assumption was that somehow the glaciers themselves did it, right? They're usually formed out of till, which is the ground up material that's created by the passage of these incredibly heavy masses of ice just kind of grinding over the landscape, right? So it churns up the ground, the bedrock, and jumbles it all together. And when it melts away, it's created this stuff called till that in the 19th century was called drift, which interestingly invokes at least the contribution of water in the process, right? So now what happens is glaciers disappear, and in this glacial till or drift, you have all of these elongated hills, these really unique, kind of mysterious elongated hills. And these are the drumlins. And we will be looking at drumlins because this is the stuff I'm talking about here is sort of like, think of this as the preface to what we're going to be doing over the next 6 or 8 episodes, right? So we'll be looking at drumlins. When we bring Jerome on, Jerome, again, has been studying drumlins. I think he would probably qualify as one of the world's experts on drumlins. And we had the privilege of spending 4 days with him up in the drumlin fields of British Columbia, October before last. Very enlightening. And the thing about it is that, and then I'll conclude this. We'll get on to the slides and stuff, which is that Shaw's critics came from a position very similar to Bretz's critics, because Shaw's critics said, well, you're saying that there was these massive, because the drumlin swarms are vast, right? The drumlin fields are vast. So the critics are saying, okay, well, Shaw, you're saying that these drumlin fields were formed by subglacial floods. Well, you're talking about floods that in some cases have to be hundreds of miles wide and tens of meters deep, right? You're saying that all of this is moving under the ice? Well, where did this water come from? He speculated, just like Brett speculated. Well, could there have been a surface melting of some kind that found its way to the base? Could there have been a subglacial lake? Were there reservoirs of water entrained glacially within the ice mass itself? Every one of those was rejected by the critics. Interestingly, the idea that you could have, like, say, a supraglacial, meaning on the glacial surface, water accumulating, or N-glacial, that's E-N glacial, N-glacial within the glacier, or subglacial, under the glacier, right? If you've got supraglacial on top, N-glacial within, right? There's no way, the critics said, that the glacial ice is going to be able to retain that much water under that much pressure to accumulate.
Oh, of course.
Yes, to accumulate the mass of water, the volume of water required for your huge subglacial floods. So, in essence,
holy paradox, Batman.
Holy paradox, Batman. Yes, I'm glad you saw that, Russ. You picked up on that immediately. Yes, the little contradiction here inherent. So they said, well, you can't provide any source for this scale of subglacial flood that you're talking about. So therefore, they didn't happen. And the idea has not been accepted by the geological mainstream. they're still floundering around trying to come up with some kind of way that the glaciers themselves are shaping the glacial till into these beautiful streamlined aerodynamic forms. See, so now, and see, and God, this was disappointing to me. We got with George Howard, what, year before last, and people, we've talked about this. We were going to do an excursion, and we still are, by the way, an excursion to Lake Nipigon.
That was 2 years ago. So yeah, we traveled with Jerome 3 years ago. So yeah, it was 2 years ago. We were going to try to get with John Shaw.
Okay, so now, Brad, will you just shift to your right? Stop right there. Okay, look, I want you to look at Brad's left ear and then go straight east at the same latitude, and you'll see Lake Nipigon right there.
Oh, yeah. I see it.
Right. We're testing the idea that Lake Nipigon is an impact-produced basin and that it formed at the Younger Dryas boundary. Okay, this is an idea. Haven't proven a damn thing. It's speculative at this point, but it has enough of the earmarks that I think it's worth looking into further, perhaps doing core samples to see if there are impact proxies, which will bring us, that idea is going to bring us right back to Lake Hind, because that's what they did in Lake Hind with Teller and Kennett and those guys collaborating to look at this study of Lake Hind. So we were going to go do a trip to Nipigon. George Howard was going to go with us. He contacted John Shaw and told him what we were up to, and John Shaw's response to him was he would be delighted to go and join us there. And then literally like 2 weeks later, he's gone. So that trip didn't happen. We were going to make it happen just because John was going to join us there. So that didn't happen. So, but it still would be coming up in the future.
Yes.
So now what I was really looking forward to talking to John about was this idea. Well, okay, let's abandon the idea of a reservoir. Let's abandon the idea of a subglacial or end glacial or superglacial reservoir and go right straight to the idea of something that could trigger flash melting on a mega scale. That's what I was really wanting to get in and see if he was open to that idea. But I think by that time, the fact that it was George Howard, the Cosmic Tusk guy that's contacting him.
He probably picked up on it, yeah.
Yeah, I would think so.
Yeah.
Well, maybe to John's way of thinking was, maybe this is it. Maybe this is how we could explain a way to get massive amounts of meltwater underneath the glaciers all at once. So anyways, 1999, that paper came out. So 21 years ago, subsequently now, I think Jerome Lessman has picked up the baton of John Shaw's work. So when he comes on, we'll be discussing John Shaw's work extensively.
All right.
Yeah, it's going to be very, very interesting stuff, I think. And then we will, we'll have to just go up and do a podcast from the drumlin fields.
Yes. Let's do it.
Wouldn't that be cool?
Yes.
But boy, I tell you, some of those days, we were there in what month? Were we there in October?
It was October, yeah. So I was just going to say,
we had some chilly days.
It was blowing snowstorm.
Yeah, we were up there in the snowstorm looking for.
We couldn't go over the plateau. We had to go back and drive around. Added 2 hours to our day because we could. It was the snow was so bad, we couldn't go up over the plateau. Yeah.
But we did see what did Jerome call them again? Doing. The scour marks on the Stos end of the drumlins. Remember?
Yeah, that was something new he was digging into. I don't recall right now.
Well, see, that is a very convincing piece of evidence that major water flows were involved.
Yep.
He had a term for it. It'll come back to me in a sec. It's break time.
Unless you want to show a map or something briefly, but that's opening up a new can.
Yeah. Don't open the next can yet, Randall.
Okay.
We're an hour plus already, amazingly.
All right.
Just put that one back on your pantry full of cans.
That's right. Save that can for after the break.
After the break. Okay.
All right.
right, welcome back, ladies and gentlemen. Second half of the show here. And before we get back into it, I want to mention our buddies cbdfromthegods.com and get an update. You got yours, and you've been taking it. How's that going?
Yeah, I got a sample. They sent me a sample
Of the Apollo?
Of the Apollo and the salve, and I've been using the oil every night before going to sleep because Randall was saying that it was helping him sleep, and that was what I wanted. I was just like, if this helps me sleep, that'll be great because I have a hard time sleeping. So I've been taking it, and it has definitely been helping me sleep.
Wow. Yeah,
Yes.
there you go.
So and it's kind of a cumulative effect. Like
Yeah.
the first time I took it, there was a little bit of help, but I've been taking it religiously each night, right before I go to bed, and following their instructions, I take the one milliliter or whatever it is. Just fill that little thing up and take it under the tongue.
You take a full dropper.
A full dropper, yeah.
Mhm.
Yeah, that's what it said. So
Yeah, I would advise someone doing it for the first time to start with a half a dropper.
no.
Just, yeah,
Unless you're Russ.
Yeah,
unless
no,
you're
I've-
Russ,
you
yeah.
just- yeah, just full.
Well,
just
for
jump
Russ, I
full
would,
in,
like we talked about earlier, I would just recommend go ahead and just, finish
That's
off
right.
the whole bottle
That's right. Yeah.
in
That's
one
right.
dose.
Just slam the bottle and you're good to go.
No, I think it's a good idea. Just start out. Of course, like for me, I guess I did actually start out with half a dropper, but would be considered a larger size guy. So, if you're 140 pounds or something, maybe the thing to do is to start with a half a dropper.
Yeah.
And do that for a week and then increase. I think probably anybody can do a dropper full. But it's probably a good idea to start conservatively and then just see how you react to it. Do a half a dropper for a week and then start filling that dropper up. Yes. Put it under your tongue and just,
Yep.
I don't even swallow. I just put it under my tongue and,
Yeah, it says to hold it there for 30 seconds to 90 seconds. So that's what I try to do.
Yeah, that's what I do
Keep it
right
under there
there.
for a minute or a minute and a half and then swallow it. And I've heard people say that other CBD stuff, they've asked me, they're like, oh man, does it taste horrible? No, it doesn't. You said it's chocolate. Now, I can't say that it actually tastes like chocolate, but
That's
doesn't
what it
taste
says
bad.
on the bottle. But
Yeah, I know.
I detect like a hint of chocolate. I would say it's a hint of
There's
chocolate.
a hint.
There's a
but
hint, yeah.
It's just not like ground up stems.
Russ,
Right.
Some of the stuff out of that.
Russ,
Right.
you just don't. You don't have the refined taste buds
Right. That's probably right.
I don't know. He's pretty good at
with the wine.
tasting with the wine. Yeah,
I bet
he
he
doesn't really
is.
like wine too much, but he's tasting it and he picks up all kinds of stuff that I always get him to.
Well, for me, one of the things, it's the sleep. It's the better quality of sleep, which affects
Yeah.
everything else,
That's right.
right?
Yeah.
But it's also the fact that I've continuing to be able to work out without getting muscle spasms, and to me that's huge, because that was my problem. Was that for several years if I would exert myself too much picking up stuff, or because I did so much physical work for decades, and at one point picking up a railroad tie on my shoulder wasn't a big deal, or throwing a 90-pound roll roofing on my shoulder and going up a 25 or 30 foot ladder and doing that for 2 hours. But somewhere between like 2013, 2015, I started getting these muscle cramps in my back. So it kind of really, it slowed me down a lot, for one thing, because I always kept in shape by working out. So get these muscle cramps was kind of debilitating. And
Yeah.
I would have spells where I would get breaks from that, and I would go, oh, great, and I would start working out, exercising, and then boom, I would get a muscle cramp like in my lower back. But here's what I've noticed, and this is, I think at this point, I'm convinced that because I go, what am I doing different now? I'm always trying stuff, but what am I doing different now? Is that dropper full of CBD oil every day, and so I'm able to now start working out again, pumping iron, all that stuff, and not experience. I haven't had a muscle cramp in the 6 weeks that I've been doing the CBD oil.
Nice.
And the muscle cramps may have been related to like an inflammatory situation. I tried to get it evaluated by a number of people. I did actually go see an acupuncturist, our good friend William Adcock, whose treatments really helped. But at the same time, it's still, they helped, but I wasn't getting the same almost total relief. So that's major for me. So we'll see how that keeps going.
So it's
CBDfromthegods.com.
Yeah,
and there's a
sorry, Kyle.
Well, I was just saying
I was just going to explain what it is that they're going to find on the website. You're going to tell them about. So yeah, basically it's a 30 milliliter bottle, right? And a full dropper is 1 milliliter. So it's recommended you can take one of those per day. So it's basically a 30-day supply. Is what I was.
There we go. Yeah.
If Randall's doing a full dropper before you go to bed, or you can do a half during the day and half before you go to bed, whatever. But yeah, it's typically a 30-day supply.
Yeah, check it out. And it's like a promo code. What is that?
Yep, that's still active for free shipping. It's RC ships free.
All right.
Yep.
Cool.
Yeah, I have a broken back, and I use a sleep app that tracks my sleeping. Right, and I've been using it because I wake up constantly, like every hour or hour and a half or 2 hours. I'll wake all the way back up, and then I have to go back to sleep, and it's terrible. I don't get good sleep. So and I use the sleep app to track this. And since starting this stuff, I don't wake up all the time anymore. So at least I stay asleep. And that's a fantastic thing.
It is. Yes.
And that's within a week of starting to use it.
That's right.
Yeah.
And yet,
awesome.
I mean,
That's awesome.
with any CBD oil, I think, 2 to 4 weeks is really considered sort of the incubation time to really start getting the cumulative effects.
Yeah.
So, yeah, I want to see a lot of these things where people who are doing all of this really cool, important work of learning and studying and researching and teaching and stuff really start being able to have advantage for all of these like cool new things that are becoming available to us. Yeah. And CBD oil, to me, CBD is right high up on the list of some of those things that we actually should have been benefiting already from for decades, but we won't get into that. So let's get back to Lake Hind for a minute. Lake Hind, we saw, was up in Manitoba, and yes, the multi-proxy study. Kyle, what does multi-proxy mean?
Multiple different lines of evidence, I guess.
Yeah, multiple. So for example, for multiple episodes now, we've been looking at nanodiamonds, we've been looking at microspherules, we've been looking at platinum or iridium. All of these things are proxies, right?
Yeah.
Because they show us that something happened, whatever it was. So, as it said, and I'll just review this, multi-proxy analysis of a sequence spanning the Younger Dryas in the glacial Lake Hind Basin of Manitoba provides insight into the regional paleohydrology and paleovegetation of meltwater rivers and lakes. So paleohydrology, we'll find this term or with the preface to terms like paleohydrology and paleovegetation or paleo-Indian, whatever it might be. Paleo just means old, Old hydrology would be the study of what's water doing now. We go out and we look at the rivers and the creeks and the rainfall, and we go, okay, the groundwater, and we go, okay, this is hydrology, right? We're talking about paleohydrology. The problem is we're not seeing the action of water firsthand. We're just seeing the after effects. That would be the difference with hydrology and paleohydrology. So paleohydrology has evolved as its own scientific discipline, which looks at the effects of ancient flowing water. Got it? Now, Kyle, what is an SER? And a PCI?
Seriously, effervescent radiology. Perfectly crustacean information.
No, Kyle. No. SER.
Oh, man.
Streamlined erosional residuals.
Oh, yeah, that's right.
That's right. Oh, yeah, that's right. You knew, didn't you? You were just pretending you didn't know.
I know I have that written down.
He's got notes, I'm sure.
Yeah.
Streamlined erosional residuals. Okay, what are PCIs?
I don't remember.
Yeah.
Oh, God. Russ.
You're failing in your job, Randall.
First one, he's just
Paleo climate.
Paleo, there you go.
Yeah,
Paleo climate something.
You're close. You started out right.
Paleo current. Go. Paleo current.
Indicators.
Russ.
Paleo current indicators. All right.
Okay, writing this down.
Teamwork.
Write it down again. Yeah.
Well, the big one for paleo is Paleozoic, right? So I mean that's old time.
Old life.
Yes.
Okay, so paleo current, that's, this idea of paleo current would then be currents that we can't visibly see anymore. Okay, so Glacial Lake Hind, as it says here, goes on to say, was dammed by the Laurentide ice sheet, and it overflowed into Lake Agassiz. So Lake Agassiz, let me find okay, this one looks pretty good. I think I'll pull up a map of glacial, at least part of Glacial Lake Agassiz here. And let's see if I can get a good one here. Kyle, why don't you go ahead too and see if you can't find, here we go. Here's this might be a good one. Glacial Lake Agassiz was this huge proglacial lake that formed around the southern, western, and western margins of the Laurentide ice sheet. You have to picture now, it's forming around the rim of the ice sheet. All right, I think we got one here. All right, this looks like a good one. I'll do a screen.
We found some if you want.
Yeah, let's see what you got. But this one is good because what it's doing is showing the drainage
hydrology.
Routes.
Yeah.
The hydrology. Yes, it's showing the paleohydrology. These are various routes by which Lake Agassiz drained. Now picture that as the ice sheet is receding back, it's losing mass. Does it lose mass? It loses weight. So because it's diminishing in mass, what's happening is you're getting an isostatic rebound effect, right? So you got to picture that when the full ice mass is there, it's bearing down on the North American continent, creating a depression. As the ice shrinks back, meltwater forms around the rim. But as the land comes up, what happens is you will have episodes where that water spills over the drainage divide because it wants to get back to the oceans. We'll see the same process at work out when we look at the Channeled Scablands. And I think that is part of the explanation for the complexity of the flood features out there, is that there were one or two or three really big flows interspersed with a lot of smaller flows that were from residual melting and drainage, proglacial drainage that occurred because the land was uplifting. So as the land is uplifting, that water, let's see if I can do it here. Let's say this is the glacier, and as the glacier melts back, the water increases, right? But then if the land rises, then the water spills over the divide. All right. So that then contributes to this complex feature. There we go. That's a good one. That's a real good one. So there you can see this was the maximum extent of Lake Agassiz, and it was most likely, it was not at any given point, it was not this entire gray area, because the basin of the lake throughout a process of maybe 3,000 to 4,000 years shifted. So it went through periodic drainings as the land rose, as the ice receded, and allowed a changing series of outlets to the ocean. But I want you to look right down here at the very southern tip. You see this limb? Yeah, that comes right down there. That's the southern outlet of Glacial Lake Agassiz. And it drained into the headwaters of what is now the Minnesota River. And I've told this story about that arrow, see that arrow, that black arrow that comes down, that is the pathway, the valley that the Minnesota River now flows in. And it was that valley that I saw in 1969 when I was at a rock concert at Eden Prairie Airport, which was built on the bluffs overlooking the Minnesota River Valley. And I got this sense of scale and variance because I could see the Minnesota River flowing down below, and I could see 3 miles, 4 miles on the other side of the valley was another set of bluffs matching the set of bluffs that I was standing on. Now, when we went back there, this was much harder to see because we went back there maybe 3-4 years ago. And of course, what had happened was there had been a lot of tree growth and vegetation growth. And apparently, maybe the place got logged over in the 30s, 20s, 30s, 40s. I don't know, because there was not that much vegetation growth and forested area looking into the valley in 1969. So the features were much more visible than they were when I made that return visit. But we stood upon that same spot where I was looking out over the valley and could see the matching bluffs, and then seeing the Minnesota River down below with a set of bluffs on either side. So that was this intimation that it was like, oh, look, this thing here is like a giant version of this thing here. Now, of course, I had no knowledge whatsoever of geology in 1969. I just had this interest I was interested in geology. I was interested in nature, the weather, the climate, everything. I was interested in all kinds of, I was a budding natural philosopher, right? So it was years later that I got actually challenged in one of my lectures by somebody who had a degree in geology. When I was talking about this episode where I saw this thing, and he said, no, that big valley was produced over millions of years. And I said, no, I'm pretty sure you're wrong. And he said, no, look, I've studied geology. I know that's, these things take long time to form, I don't know, but I tell you what, that motivated me to really, really, look into it. And of course, what I can now know is tell you that, oh yeah, well, that valley was created by Glacial River Warren, whose peak discharge was 4,000 times greater than the modern Minnesota River, right? I know that now, right? But the cool thing is that flood that created Glacial River Warren, 4,000 times greater than the modern Minnesota River, which ultimately drains into the Mississippi, just there by St. Paul, Minnesota, that was the southern drainage of glacial Lake Agassiz.
So you mean to tell me that at the time you didn't look at that geologist and say, well, the paleo current indicators suggested it was a giant flood?
I didn't say that because I didn't even know the term then, paleo current indicators. Although not long after that, I did learn.
I know how you feel.
What it was. I mean, I would say that, I had a abiding interest in geology all through the 70s and a lot of observational stuff, but not hardcore study until, I tell you what triggered it was when 1980, when the reports came out that the Earth got struck by an asteroid, and that really galvanized a resurgence in my interest in these things. And that is when I would say I really started scouring the geological literature and thinking about geology and buying books on it, reading about it. It was another decade later before I actually began taking courses on it. But yeah, that's pretty much how it started. And the idea of an asteroid impact really fired my imagination.
And that was right after Mount St. Helens too, so that definitely woke a lot of people up and said, what's going on with geology and volcanology and earth changes here? So yeah, that was right in the same year, within a few months of each other.
Yeah. Would you pull that map up again? And let's see if we can locate where Lake Hind is on there. Let's see. Okay, cool. I think we can just about see it. We've seen the southern outlet, and I'm gonna this actually in our, we want to call it a pilgrimage, where we led Graham Hancock across from Portland to Minneapolis. That was one of our last stops, was at the southern outlet of Glacial Lake Agassiz. And so I have some photographs there of some interesting features that formed. But if we go up right about where you see Manitoba, do you see Manitoba?
I'm not real clear now.
Okay, so okay, you see
It's been a long time since took geography.
Okay, so you see North Dakota. Can you find North Dakota? It's next to Minnesota. Yeah, that's North Dakota. Now, directly above there is Manitoba, and then, yes, that's Manitoba. And that borderline, north-south borderline is the border between Manitoba and Saskatchewan. Okay, so if you go down right in that little corner of southwestern Manitoba, and your mouse is right now kind of on a little black smudge there, that's the area we're interested in right now. And that's the area of Lake Hind. So go ahead and close this out. And I'll go back to here. All right. Here we see I've put in a little blue polyline down here to represent Glacial Lake Hind. Pretty close. It's approximate.
Yeah.
You know, a couple of the maps I've looked at weren't exactly the same. Just depends on which phase of the lake we're talking about, but this is pretty close. And this was right next to Glacial Lake Agassiz, which, if you look here, the basin of Lake Winnebagosh and Winnebagosis right here, that was where the edge of Lake Agassiz was. So this was very close to Lake, and then it at some point actually drained into Lake Agassiz. So let's go through here. Here you can see up here, upper right corner, you see Lake Agassiz, and there's Lake Hind, right? And this little connection between the two. And this one is actually showing Lake Hind crossing a little bit into North Dakota. We'll skip that for now. We've talked about that. We'll keep going. Okay, so Lake Hind, here's one of the things they found. And this actually goes back to the Firestone team, because the Firestone team in 2007 got samples from Lake Hind, and they were the first ones to find impact proxies, including nanodiamonds. So here we see the graph that we've looked at showing the peak, the sudden peak of nanodiamonds in core samples from the sediments that were the bottom of Lake Hind. In those core samples at the Younger Dryas boundary is where the proxies were found, including the nanodiamonds, the platinum, and the iridium. So, yes, it says here, Firestone at Alia, 2007, reported anomalously high concentrations of thorium, uranium, hafnium, scandium, et cetera, in Lake Hind and at Blackwater Draw, New Mexico. They also reported a similar pattern of enrichment at two sites in Italy containing layers deposited during the approximately 66 million year ago Cretaceous Tertiary impact, which I find very interesting, that we kind of see that the whole Cenozoic, in a way, is now bookended by impact events. So as it goes on here, unique and distinguishing geomorphic and sedimentological features related to catastrophic floods are present throughout the region to the west of Lake Hind, particularly along the Cirrus River, and include deep, steep-sided channels that lack tributaries and have a uniform width along their entire length. The 1 to 3 kilometer wide scoured sub-upland zone, we'll look at what that is. But number 3, very important, streamlined hills in the sub-upland valleys and boulder-armored floors on some sub-upland valleys, scattered massive boulder gravel deposits in the valleys. These channels all head in proglacial lake basins, which have been interpreted to have abruptly released their waters and eroded the downstream valley in a few years. The chronology of these flood events is poorly constrained, although researchers have concluded that all flood channels in the Canadian prairies were not eroded at the same time. which of course makes sense because we're ultimately talking about having to get rid of all of the ice of the Laurentide ice sheet. And this didn't all happen at once. Okay. So Sun in 1996 presented evidence for a number of floods that impacted on the Lake Hind Basin. And there is evidence for more than one flood in many places to the west. And then this is significant. Most floods appear to have occurred close to or just before 13,000 calibrated years, 13,000 calibrated years ago, including a particularly large one through the Cirrus River Valley that emanated from glacial Lake Regina. Other channels west of Lake Assiniboine and the Keoapel valleys may have experienced catastrophic floods a few centuries later. Thus, the water-scoured landscape of Saskatchewan downstream from these proglacial lakes as far as the glacial Lake Hind Basin clearly indicates that one or more large floods helped shape this region. So we looked at this. This is what's there now, is the Oak Lake. We saw that unique arcuate feature. And then we saw the sand deposits, which are these sand deposits right here are paleocurrent indicators. And if you look up here at the sand, the transport rows, it's called, it's showing the dominant orientation of the flood sediments. And notice how that arrow runs parallel to these sand deposits, which are represented by the gray splotches. So this is showing currents flowing from upper left to lower right. Up here where it says Verdun, down this way to Cirrus. And in the wake of these sweeping currents moving across the land here, it left these sand deposits in its wake. And so here we have one of the Assiniboine River Valley or channel. You can see it right here. Notice here, Oak Lake. Look at Oak Lake right here. And then just to the north of Oak Lake, we have this wide channel. Here we'll look at a little closer at it. And when we look closer up, we see that we have a very large channel compared to the river that's flowing in it. So this river, the Assiniboine River that's flowing in it, did not create this channel. This is not created over millions of years. For one thing, we know that absolutely for a fact because the glacier, whatever was there before, would have been obliterated by the glacier. So this channel formed, it's part of the process of the glacier disappearing, melting away. And so what we have here is called an underfit river. The river is much smaller than the channel in which it flows, okay? So this is part of that Assiniboine channel right in this area here that comes down, wraps around, goes back to the north, and flows off this way towards Brandon. And yes, so immediately above the minus 33 centimeter in subunit B1, they're calling it, which is just one of the sedimentary layers within those core samples and within stream outcrops. Actually, the rivers have exposed cross sections, sedimentary cross sections in which the Younger Dryas boundary can be found. So the mineralogical and elemental evidence supports the occurrence of the Younger Dryas boundary cosmic impact event, including concentrations of magnetic microspherules, a distinct peak in nanodiamonds, and anomalously high concentrations of platinum or iridium. Yes, the high-temperature magnetic spherules exhibit morphologies and chemical compositions like those found in sediment dated to the Younger Dryas onset at approximately 40 other sites across nearly a quarter of the Earth's surface. So then we talked about the high-energy seismic pulse, the thermal pulse, and then we went to a Google Earth image. And right in here, you see there's Oak Lake. Doesn't show up very well on this, but you can kind of see this darker blotch area right here. That is the basin of Lake Hind. So it was in there, just north of this little town called Hartney, where samples were taken, and the Cirrus River flows through there. So the Cirrus River exposed a sedimentary outcrop. A couple of things I want to call your attention to is these dark features here. These are a series of giant spillways. You can see them down here to the left in North Dakota. And then we've got some other interesting things. We've got some uplands right here. Two of them, which are considerably higher than the surrounding plain. And there is a map, roughly the border of Lake Hind when it was at its maximum extent. So when we go up into these valleys here, these spillways, we begin to see things like this. Now, as you're looking at this, notice here where you've got the squares that are cultivated areas, right? And you can see there's a pretty distinct change, a shift between the cultivated area and the area that can't be cultivated. And again, you look on this side, this here is about roughly 5 miles across. And what we're seeing here is the water limits at the maximum flow through this feature, through this spillway feature. You know, right over here, if you can see where my cursor is, roughly would have been the northern edge of the flow, the paleo flow, if you will.
Let me interrupt you a second, Randall.
Yeah.
The difference in landforms there, you're drawing a distinct difference between the stream area and the areas on either side that look very spongiform. Is there a name for that? I mean, it's like I said, it looks very spongy, very marshy, but it's not.
Hummocky.
Oh.
Hummocks. Yes, because here's the thing you got to bear in mind. At the maximum flow, peak flow, this entire scene was submerged. Right? That's number one. But then what happens, and that is referred to as a sheet flood, right? But sheet floods always tend to try to concentrate, and they will find anything they can, and they will begin carving a lowered area in which the water can then will then use as its route. And that's what we see here. So it would have been a sheet flood first, and then you would have had the concentration of the meltwater into the stream. And you can see the river flowing, how small this river is right down here. See this meandering, winding back and forth, which is the river flowing near now. And we use the term sub-upland. Well, the sub-upland would be the area, this darker green is the lowest channel. And then as you come up a little bit, you've got the sub-upland here, and then you've got the upland. So the upland is what's being cultivated and has the rectilinear pattern of fields and roads. The sub-upland is between that and the inner channel. So this is the inner channel right along here, the darker green. And it tends to be darker green because it's lower and it stays wetter and moister, and so there's going to be a concentration of vegetation growth along the inner channel. And here's just a Google Maps, and you can see something interesting here. Here you see kind of a bank along this side. You see the river meandering around here, much smaller than the channel. This is the Cirrus River and spillway just north of the U.S.-Canadian border. Note the large-scale SERs. Where are the SERs? You can see them faintly right here. See that? Streamlined erosional residual. Look at this bigger one right here. See that? Well, this tells you that you can see that the water was all the way over here. And in fact, would have been right off of the screen to the east, because all of these little lakes are occupying little holes that were carved out by the passage of these the meltwater. Typically, too, in the meltwater, you would have had many pieces of glacier, like icebergs, that when they come to ground, melt away. Their bottoms will be buried into the glacial till, and then they melt away, and they form what are called kettle lakes. Now let's go to this one. Here's a Google Earth of the same image. Check this out. See this feature right here and this feature, and you can kind of see where the water flow bifurcated right here. So at one phase of this meltwater flood, these things would have been islands, you see? Now take a look here. You can see the river, the modern river flowing along here. And what we're seeing here is the basin of the ancient gigantic river. And look, here is the transition right here. So from here all the way over to here is the Cirrus spillway, is the channel. And then in the channel itself, you have the streamlined erosional residual. And then this is the bigger one. What we're seeing right here, let me go back. You see, we're looking at this. We're looking at this trough right here when we see this right here. Is that making sense? Yeah. And then the river itself. So the point people have to realize is that this little river over here did not create this channel. What it's doing is it's taking advantage of the channel that's there, and it's just occupying that channel. And we saw this, so I'm going to keep going here, and then I'm going to
got to start wrapping it up here too, Randall.
Okay, then I'm going to shift to this, and we'll pick this up next week. Brad doesn't have his hat on yet, but
I'm being generous.
Oh, okay. Thank you, Brad. Okay, so let me go back to here, and all right. So here you can see part of Glacial Lake Agassiz. And
why isn't Hind just considered to be part of Agassiz? Like, were they at different times? Or,
well, look here. Look here. Do you see Regina where my cursor is?
Uh-huh.
And you see this would have been where Lake Hind was. And it did eventually merge with Lake Agassiz.
Okay.
But for a while, it was separate body of water.
All right.
Okay. So this is going back to the work of like Kehew, Lord, several others that have done work on the mid-continental glacial lake spillways. It says here in the mid-continent region, they consist of narrow, deep trenches connecting proglacial lake basins. Geomorphic and sedimentologic evidence from the Cirrus and Des Lacs spillways in Saskatchewan and North Dakota indicates a catastrophic drainage of glacial Lake Regina, which would have been this lake right up here, obviously named after the town that would have been in the lake. So, and here's an important point. Modern rivers in the mid-continent region commonly occupy former glacial spillways which connect proglacial lake basins. Some spillways were later utilized by major rivers draining the Rocky Mountains. Glacial lake spillways eroded along the Laurentide ice margin. They're variable in size, but generally are extremely large relative to most modern river channels, because most modern river channels are occupying these giant spillways. So here in this Google Earth view, we've got the yellow arrow pointing to the basin of Lake Hind. We've got these two upland regions that I'm finding very interesting that we're going to come back and look at in more detail. And then we've got like named, here's the Des Lacs spillway, named after the river that's now flowing there. B is the Cirrus spillway. C is the Moose Mountain spillway. D is the Pembina. And look, Pembina spillway is flowing out away from the Lake Missoula Lake Hind basin. Assiniboine, which I don't have labeled, was this up here, and it was draining into Lake Hind. And then, let's see, E down here is Girard Lake Spillway. So we're looking north.
There's just an overall pattern to that to all of the land there in that image that really just looks like you can see,
you can see this
the flow.
Oh, yeah.
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 That's amazing.
It is amazing. And this is from John Shelton's book, Geology Illustrated, which is a classic. This is his view of Glacial Lake Agassiz spillway at the Minnesota-South Dakota border. And this is modern Big Stone Lake. So this is where we took Graham as our last stop before Minneapolis, which was the southern outlet of Glacial Lake Agassiz, which, as I just explained, fed into the Minnesota River. And this was, so John Shelton was a pilot and a geologist. So he has this book of these really great photographs of all of these geological features. So this is, as I say here, this is a textbook example of an underfit stream. Note the diminutive size of the modern stream in comparison to the channel it occupies. This is Cottonwood Slough in South Dakota, a relic of the glacial meltdown.
Yeah, and the farmlands there give you the scale. That's an enormous channel. Holy crap.
And the highway. Yeah. And I mean, it's a full-size river. So
maybe you got into this last week when I was having my little micro nap there. That basically the draining of Lake Agassiz, though, has been the going hypothesis or theory, I guess, for the Younger Dryas, right? Before the whole comet hypothesis came along, that's been the reason why we had this sudden climate change. It's been the draining of Lake Agassiz.
This would have been the eastward draining of Lake Agassiz into the North Atlantic, which shut down the thermohaline circulation, causing a cessation of the transport of heat to the northern latitudes. And yes, that was what was believed by Wallace Brecker and others to be the main cause of the Younger Dryas cooling episode. But we'll look at that because that's not generally accepted now.
Right.
Okay, so looking at this pattern, you're going to see the residual effects of the flowing of the water over the landscape. And here's the important thing to understand is that these features are everywhere about us underfoot. We just don't recognize them generally, though, because a lot of times, like here in the Midwest, they tend to be more subtle. I mean, you could drive through one of the spillways and not really even understand what you're doing. You're driving down a hill, you're going across a mile, 2, 3 miles wide, and then you're going up another hill, right? And you don't necessarily even know that you've just gone through this huge spillway. And in the spillway and in this water flow, you see Scabland complex about 5 miles east of Minot, North Dakota, and note the streamlined forms that you're going to see, and you'll see a lot more of those. When we look at, here's 2 giant meltwater spillways converging about 4 miles west. We're looking to the southeast. So you see the Cirrus spillway coming in from the left and the Delac spillway coming in from the right, and then they merge right there at Burlington. And again, you can clearly see the demarcation between the 2 different types of landform in that you've got the cultivated area up here on the uplands, but then down in the spillway itself, you've got sediment, which could be great cropland, except this is the modern, the sediment layer that was left behind in the spillways is now the modern floodplain. So if you have a flood in any of these rivers, it tends to spread out and drown the bottom of the channel. But here you can clearly see these huge channels. And again, and look at both of them. You see the rivers flowing in them. These are underfit rivers. Those rivers are just simply taking advantage of the existence of these spillways. They've been captured by the spillways. They did not create the spillways. And so we're going to make a quick jump to another planet. We're going to look at Mars because we're seeing megaflood features on Mars that have a lot of parallels to what we're going to be looking at. And we're seeing the erosive and depositional effects of massive megafloods on Mars that have created the same type, the same suite of geomorphic features that we're seeing associated with megafloods on Earth. So, as it says here, now check this out. Notice the streamlining and notice these aerodynamic forms. And here you can very clearly see that water is involved here. As it says, the blue arrows show the direction of water flow. So you've got a major flow coming through this way. You've got water flows coming down this way. Streamlined islands have the orange arrows pointed to them. So look at this. Here you have a streamlined erosional residual right here. You see that, Guy? Elongated into this aerodynamic shape. You have scablands, cataracts, and grooves carved into the channel floors are similar to features found on Earth where large floods have occurred, such as the Channeled Scabland of eastern Washington state. So as we go through some of these, you'll see, we'll look at these in more depth next week so we can really begin deciphering what we're looking at. But again, notice down here where my cursor is, you see you've got streamlined forms down here, which would have been islands within the stream. You see?
Those are all really well preserved, too.
Oh, well, yeah.
You know, how old or recent can they be? They've got huge windstorms. They've got moving debris around. And it can't be 1 billion years old.
Well, one of the things that could possibly be used to at least relative dating is the cratering. For example, if you look at this, clearly, like look at this crater. This crater had to have been formed after the flood. Because you're going to see that in some of these images, let's see. Okay, yeah, here, look at this crater.
Oh, I've got that one. Oh, man, I've got a poster of that in my rack here.
This is an awesome one. Now, notice here, the crater existed before the flood because the flood has created this tapered, streamlined form down current. So in this case, notice that the flow would have been from the lower right to the upper left. Also, something I want to call your attention to is are these striations within the floor of the paleo channel? Because we're going to see that's going to be a common feature that we see in megaflood features on Earth. That, again, a lot of these features are going to be subtle. Some of them are more spectacular. They run the gamut. But we're going to learn to recognize the subtle features as well as the spectacular ones. But again, notice I'm wanting to get people to understand the streamlined forms. And here, notice the channels, the scouring that has taken place within this channel. And you notice the meandering, the branching here. So you had a major flow cut this channel, and then you had a diminishing scale of residual flows that created the textured bottom of the channel.
Russ, there's a racetrack ply on a huge scale there.
Yeah, maybe so. Now here's a beautiful example of an SER, Kyle, a streamlined erosional residual. So this would have been a temporary island within the stream. This is a flood channel in the Tharsis region of Mars. It's approximately a 3/4 mile long, which is also very typical length in the scale of drumlins. Check this one out. Here's your streamlined islands. And pretty fantastic stuff, isn't it? And here you can see
the other thing I would note is that impacts obviously don't happen very often in any of these photos.
There's just
but
everywhere.
Like you'll notice that this impact would have been post-flood.
Yes.
And these are probably relics of craters that were pre-flood that have been eroded and buried.
Man.
Yeah, check this out. So here, the Shelbatana Vallis, near where it flows into Christ Planitia, right here. So this little red box is this picture here. Flow towards the upper part of the screen. Notice here, you've got this. This is called longitudinal scouring because it's long, right? Think long, longitude, and it tends to be just like longitude on Earth. Your lines of longitude, your meridians all kind of run parallel. So you've got that longitudinal scouring here, which is water flowing through, probably dragging larger sediment along the flow of the bottom of the current flow, because some sediment will be small enough that it's picked up and entrained within the water flow, but there may be sediment also that is not being lifted in the flow itself, but the force of the flow is still enough to push it along the bottom of the channel. And notice the cool streamlined forms. You've got a little streamlined form juxtaposed on a long streamlined form. Now, clearly, when you look at this, the crater was already there, wasn't it?
Yeah, it's like the cause of those streamlined forms.
Yes, exactly.
Yeah,
exactly.
And it looks like there might be another one at the tip of the big one down there too, more eroded.
Yeah, down here.
Yes.
Yeah. Yep. Now, when we get back to the Glacial Lake Hind area, what we're going to do is we're going to be looking at these various forms that we see out there. Here's the map where, again, you see the Assiniboine River spillway coming here just north of Oak Lake. But then we're going to be looking at some of these features, and you're going to see the streamlined forms. You're going to see the underfit rivers. You're going to see the branching patterns where they sometimes separate and then reconnect, right? So here's two giant meltwater spillways that I had a Google Earth image of earlier. So here's the Pembina spillway at the U.S.-Canadian border. And if we zoomed in, we'd see the same thing, that the river flowing in there is diminutive. And then we get to the southern outlet of Glacial Lake Agassiz. And notice we have two paleocurrents converging here right at that outlet. And this is where we stop. This is actually Big Stone Lake down here. Big Stone, it's called. And let me jump over to some photographs here. Let's see.
Brad's got his hat on.
Okay. We'll go 60 more seconds and we'll be done.
I thought Mars was a good place to tease and wrap it up. But yeah. Do what you got to do. It's good stuff.
All right. So are you seeing this photograph? This is in the outlet of Glacial Lake Agassiz. This is called a whaleback, a new term, whaleback. Let's see. Now, what's happening here is you've got these exposures of this bedrock, this granitic bedrock that has been scraped first by the glaciers moving in and then by the floodwaters coming off of the receding glaciers. And let's see if we can, I don't know what that's doing.
What is that?
I think this was Brad who's trying to drive up a steep embankment there. And let's see, let's go back.
Carrying the dog on the roof, right?
There goes all.
Okay, so it's not super spectacular, but you've got these whalebacks, and you can see more of them out here. And if you look at this from the air, you can see that we're in a spillway. And the floor of this spillway has these eroded granitic outcrops. And then in the distance, you're going to see within these trees, there's a lot of large boulders that have been deposited. Okay, so here now, you can kind of get a sense. Here's the opposite bank of the spillway. So this whole wide spillway, and we're kind of at a prominence, so standing at a whaleback prominence in the middle of the spillway here. So it's about the same distance behind us here. And this was the outlet of Lake Agassiz. And we're looking right up here into the outlet of Lake Agassiz, standing on a whaleback, rounded rocks. And if you look at this, you'll see the boulders, the big stones down on the floor of the spillway. Okay, check this out. There's Brad. Here's a whaleback. Now you can see from this, the blunt end is upstream. So the glacier and the floods both came from the right, moving towards the left. This is Graham Hancock down here, hurrying back to the van because he was getting swarmed by giant Minnesota mosquitoes. Anyways, okay, so then all throughout the spillway mouth, you see this kind of stuff, big rounded boulders.
Oh, yeah.
And this is why it's called Big Stone Lake, because all around flanking the lake are hundreds or thousands of these big rounded boulders that came discharging out when Lake Agassiz drained to the south. And like I said, this was a bird sanctuary, which I'd love to go back to again because quite amazing in terms of its birds. But we'll end it there. We'll be picking this up again, and we're gonna basically extend outwards, and we're going to begin to examine essentially the whole North American continent to try to decipher the particulars of this catastrophic glacial meltdown.
Excellent.
Kyle, was, I don't know whether it was you or Russ that said something about seeing the drainage patterns in the photos and having a realization. I had the same kind of realization when I saw that the map that's behind Brad tacked on his wall. When you see the North American continent like that in that satellite photo,
We're coming to that, Mike.
and you see the drainage patterns, it is astounding.
Yes, we're coming to that, Mike.
Excellent.
Okay, no spoiler.
Yeah.
That's
Spoiler
what I'm
alert.
waiting for.
Mike's trying to.
They're not hiding. They're there if you look at them, and those underfit rivers are all across Montana, all across the Dakotas, and Minnesota, and they're not.
In fact,
they're
it's
not hiding.
most of the rivers.
Yeah,
Yeah.
we have them here.
Yeah, you guys got them there.
I'm going to stick up for Silent Mike. He said nothing the entire show, man.
Well,
he says one thing, and
You guys are like, shut up, Mike.
Well, what we need to do then is, Mike, you know, if you could like submit a written list of prospective comments, then we could vet those comments. We could approve. Okay, Mike. Yes, you can make you can make that
say
comment,
that comment, Mike.
but not this one.
Okay.
Okay. No,
All right.
I like
you're
it.
absolutely right, Mike. And Mike, I want you to hold that thought because we are definitely coming back to that. Yes.
And I'll have more maps.
I'm
And
glad to
we'll
see you're finally thinking bigger, Randall.
Well, yeah, I've resisted your advice to me, Mike, for years that I'm not thinking big enough, and I've finally just succumbed. I've thrown in the towel. I've caved in. I'm going to start thinking bigger.
Bigger is better. All right, awesome show, man.
Excellent
As
show.
I say
Thank
to
you, as
people,
always.
you know, I try to limit myself because, you know, when you start looking at the whole cosmological perspective, it's just too much to take in. So my personal preferences, I limit myself basically to the metagalactic level. I mean, you've got to draw bounds around it somewhere.
Yeah.
So
That's kind of small, though. You should.
Think
Well-
metagalactically, act globally.
Yeah.
yeah, think metagalactically.
Yeah. Let's go galactic cluster. or
There's a
something,
bumper
you know,
sticker there for you, Rad. Put that on the site.
That's right.
Okay. Oh, RandallCarlson.com. Go
That's
there.
right.
Bam. It is
Howtube.com. Yeah, we're
Yep.
partnering with Howtube. This is exciting.
Yes, it is.
I think
That's right.
we got big things in the pipeline.
Yes,
Yep.
big things in the pipeline, and yet sadly we had to postpone the Scablands trip.
Yes.
Yep.
That happened last week, and we're very sad.
Grumble,
But,
grumble.
Everybody's sticking in there with us. We're gonna reschedule it. We're working on a definite date, but
Looking at May.
But
yeah.
that does
We
mean
gotta
that
get past
people
this.
have time to set their money aside. They got time to really learn about it over
Yeah.
the next
Yep.
3 months of shows that's
And we're
going to make them realize I've got to go.
that's
and,
right.
and we'll
We're
fill
changing up
2
the
trips
schedule.
for May.
Yeah, we're
Yeah.
changing up
Hopefully
the Zoom conferences schedule for everyone to come to, so Randall can tell us all about everything that we're about to go see, and we can learn about, what are these things called?
Streamlined erosional.
Seriously, error something or other.
Seriously enticing residuals. I'll make some concluding words here, and they'll be short. What I'm attempting to do is to make the case that planet Earth has engraved into it an epic tale about tremendous Earth changes, tremendous planetary changes and upheavals. One of the things that's happened is because of dogmas about the things that have been allowed to happen on Earth, a lot of this stuff has been overlooked. And of course, only within the last few decades or last generation or two have we had the technologies to be able to see the big picture. How many decades were people traveling through and across these spillways without having the slightest clue what they were? But now we have this enhanced perspective, and this enhanced perspective is allowing us to see the big picture. And what it is revealing to us is an epic tale of planetary change that has affected our ancestors and is still echoing in current events today because of what is happening. And so, but in order to read this epic tale, we have to know the language in which it has been preserved. And this is the language of geology and geomorphology, stratigraphy and sedimentology, et cetera, et cetera. And so when I'm teaching you these things, streamlined erosion residuals, paleocurrent indicators, this is part of the language. So one of the objectives of this series of podcasts that we're doing here is to basically reveal this language, to translate this language now for the 21st century, utilizing all the tools at our disposal so that the human species can become aware of this epic tale that's under our feet that has been waiting 13,000 years to be deciphered.
No doubt. It is episode 44, and I'm going to demand that you have one of those statements for the end of every episode from here on out. That's awesome.
Yeah.
We're going to
great.
put that on the website.
Yeah.
That's awesome.
That was really good. All right. Everybody can get a hold of us, cosmographia1618@gmail.com. And everything else is in the show notes. All right.
We're gonna have quite a few more emails become available to separate things that you're interested in. If you want to volunteer, if you want to send us research papers, if you want to get involved in a tour, we're going to have separate email addresses so people can get right to what they want to get to faster. And we're going to have a system to respond.
Excellent.
We're getting there. Thanks, y'all.
We are. Thank you.
Thank you,
Good night.
gentlemen. Good night.
Good night.